This video is about recycling the parts from a Genetix Q-Bot CNC machine I picked up many years ago and transforming those parts into two very unique desks. One being a sturdy garage workbench for projects and the other an Octagon computer workstation so I can sit in the middle of a multiple PC and monitor setup and easily rotate between the various workstations as I needed from one central location. Hello everyone. The format of this video is comprised mainly of pictures with a few videos of the end product, the desk that I built, and the methodological format of how I recycled the Genetix Q-Bot into these two desks. The garage desks were built about 5 years ago for the garage version of the desk, and the Octagon desk was about 2 years ago. And I didn't have at that time in my mind the thought of making a video of how I actually did it. So the fun part of actually constructing this video was going back and looking at what pictures I had and what videos I had, and then throwing those into a kind of logical order of how I came up with the designs and how I actually created these two desks. And I hope you'll enjoy this fun project that I'm putting into a video for you. Let me know in the comments below if you have any thoughts of, after you watch this, whether you would have added some different stuff to the desks or completely did something different, or what you liked or what you didn't like about them. Thank you and enjoy. This behemoth of a box sat in my garage for years, mainly just used as a clean room workbench to build PCs and store items I wanted to keep clean in the garage. I've worked with 80/20 aluminum extrusion designs before at a previous job and saw the potential that this Q-Bot frame had with all the extruded aluminum structures, fasteners, thick aluminum plate, and plastic panels, so I decided to disassemble it and build the first desk out of parts, the garage workbench. Let me talk a little bit about the 80/20 components, the extruded aluminum. I'm not sure if it's actually from the company 80/20, but 8020.net. You can go online and check it out. They've got tons of different types of what we call extruded aluminum profiles, the profile here, and they extrude it to a certain length. And the cool thing about these is they have what they call T slots, and these T slots you can fit what you call T nuts or various other fasteners. This nut is actually a self-aligning T nut with ball spring. The cool thing about this little ball spring right here is once you slide it in place, it stays in place. I can turn this wherever you want. So if you're mounting, let's say, an angle or anything to it, you can move your T-nut wherever you want, take the screw out, and it'll stay in place. And then when you put your angle back on it or whatever, you just screw it back on, and it's back in place, and it can be readjusted wherever you want. Cool thing about the T-nuts, they come in various sizes for different types of screws. But depending on your series for the extruded aluminum, the Genetix Q-Bot came with all metrics. So these are what you call a 40 series. The base one is 40 millimeters wide, but this is an 80/80, 80 millimeters wide by 80 millimeters wide. And it also came with the 40 by 80. So 40 series, 40/80, 40 millimeters wide, 80 millimeters tall. That's what's cool about these. At first, I deconstructed the upper frame down to the 1/2-inch thick aluminum plate, but I'll first show the aluminum extrusion frame without it to visualize the garage desk frame. The overall dimensions were 4 feet wide by 6 feet long, and the lower frame had an 18-inch opening that used to have black plastic panels on it. The concept is to create a desk that is the existing 4-foot width, make it a 32-inch depth, and keep the lower height that has an 18-inch opening that I could modify and cut down the existing plexiglass doors to fit. I then went to cutting the thick aluminum plate and tried at first a cordless saw with a metal grinding blade. This proved to cut straight but worthless once I killed the 20-volt battery and only got about 6 inches of cut within the time it took to kill the battery. I then figured the secret by using a Sawzall reciprocating saw with a metal blade that was able to cut through the thick aluminum but wasn't the best at a straight cut, but I didn't care since I just placed the crooked side to the back of the desk top and bottom anyways. Quickly, I cut two 32-inch plates and it had a smaller strip left over. As you can see, the Genetix Q-Bot took up a lot of space in my garage. The red outline is only the bottom part, so imagine extending those lines up another 4 feet. I was happy to free up this space and start building the garage desk. These sliding doors occupied the upper portion of the Q-Bot, and I wanted to recycle 4 of them to make shorter sliding doors for the new garage desk. I just needed to cut down the plexiglass and the vertical aluminum frame and reconfigure them for the smaller space. I then laid out all the existing 80/20 parts to inventory what I had. Next step was to choose what parts I needed to build the overall frame, with in mind trying to use the existing lengths since the mounting methods were already machined into the ends. I'll go into that process a little later. I did, though, need to cut 2 of the longer beams to make up the depth of the desk since there was no exact length for what I cut the desktop depth to. After cutting the 2 long pieces almost in half, a little less, the overall frame was quickly and easily built due to the existing connecting methods using anchor fasteners and T-nuts and bolts. The 4 ends that I had cut, I used aluminum plates and T-nuts with bolts to secure them in place. Next was adding some more features in. I added in the heavy thick aluminum plate desktop and bottom, technically a desktop on the bottom for storage. A shop light I hung from the overhang member. I attached the old CRT monitor mount minus the CRT monitor and installed the newly created short sliding doors to the front and back of the desk. The sliding door frames were easy to modify and build and easy to install with the recycled T-slot specific hardware that the Q-Bot had. There were only a few more items to add to complete the desk. As said before, I only have a few pictures of the original completed desk, so here's the best view I have. I added a LCD monitor to the CRT monitor bracket by adding a few bolts to the base of the monitor and then creating some plexiglass side panels for the other existing doors. I just used the plexiglass and cut them to the rectangular shape of the ends of the desk and attached them to the 80/20 frame with recycled aluminum angles and plastic bolts that used to hold the black plastic panels on the Q-Bot. The first desk was finally complete. One of the main reasons I did not want to modify the actual lengths of the extruded aluminum structures was the way that the horizontal beams attached to the vertical beams was with what you call anchor fasteners. These little kind of expensive. I think they're around $3 to $4 a piece. Fasteners, and they require a machining process to the end of the extruded aluminum. So these are parts I actually cut off a while ago. They would plop in place and the T-nut would go in another slot. So to make this easier, if you actually slide these T-nuts in place, you can put this anchor fastener at a location where you want to mate another member to it horizontally. You pop them in place, and then you just tighten up that nut. What it does is it creates a compression tension bond, pulls this member to this one. And notice how there is one, but there's actually 2. They're on opposite ends. The actual anchor fasteners, and with every single horizontal to vertical member, there's always 2 anchor fasteners at each end where they're located. So that is the one reason why I did not want to mess around with cutting off any of the existing members, because then I wouldn't have this fastener. I don't have a end mill to actually make this. But when I get around to it in the future, when I do the Octagon desk, I'll show you the trick tip I did and figure out how to actually do that. Eventually, I took apart the back panel, the part that had the light hanging down from and originally my monitor mounts, because I needed parts for the next build, the Octagon desk. This is the configuration it stayed in for years. The solid 1/2-inch thick aluminum desktop was great for being a solid work surface. I had a drill press attached to the top, a dual monitor support on the back rail, and although the aluminum plate had many holes from the Q-Bot days, it didn't affect the function as a garage desk. Fast forward to the end of 2022, current today. The video above that you're watching is actually after I kind of cleaned everything off of this desk and I was getting prepared to take it apart because I have a whole new project I wanted to do called the media room desk. So I wanted to transform what you see above into a completely different desk. This gives me the perfect transition into the next desk that was created with the recycled Genetix Q-Bot, the Octagon desk. My original office design started with transforming one room into an office by creating a T-shaped desk With this T-shaped desk, I created a office supply storage cabinet on the end, some monitor supports, and I had some shelves in the back I could put stuff on. The original design was to have my own side and then have my wife share the office with her side. But then that became my side and my side. I would always find myself working on CAD projects, then jumping over to video editing and rendering those videos, then working on educational stuff, and then I always going back to gaming, and then I found myself using both simultaneously a lot. The Octagon desk was envisioned. And this one was actually spawned off of a class that I taught at a local community college. It was called Reverse Engineering using SolidWorks. And one of the projects I gave was basically trying to reverse engineer an 80/20 desk from a imaginary desk that I made up online. I made up in actually SolidWorks, and have the students try to recreate in SolidWorks based off of knowing how the components go together. And after this project was done, I decided, hey, wait, the desk I currently have and I was working on, I had a big T-shaped desk that I made previously that I had on one side my gaming / video editing computer, and on the other side I had my CAD engineering teaching PC. And I always bounced back and forth. So I got this idea, hey, wait a second. This idea that I gave the students, why don't I take the extra pieces that I had left over from the Q-Bot and create a awesome desk where I could sit in the middle and be able to technically work on two computers simultaneously without a switch. I don't have to use the same monitor. I like to have different monitors, a triple monitor set up for gaming and maybe a wide screen and a 4K for CAD and video editing. So I wanted to create this desk that was somewhat a sit in the middle and be able to just rotate your seat and be able to work on whatever you want, whenever you want. And here's where it starts. I first determined what pieces I had left over from the garage workbench, and then decided I needed more pieces, so I took apart the back portion of the garage workbench. I then took measurements of all the pieces I had to determine what could I make from them. And then I went to the primary step of trying to figure out how big could I make this desk and what shape would it be. I'll do a quick overview of the how I got the overall outer dimensions of the Octagon desk. So I started out with a sketch of the existing room, came up with the overall dimensions, X and Y. I figured out what I had in the room that I wanted to keep. I wanted to keep the shelves. They're 16-inch wide shelves on both sides. I had the end of the existing old desk. There was the end portion I made, I think it's about 40 inches wide, had a nice drawer and a storage spot below it. I wanted to keep that, so I took the overall dimension of between the closet door and the back wall and decided that's where I was going to cut the end portion off. I was going to move that desk portion and reuse it to the corner of the room, and that's basically what I did. There was the printer cart I had, a double stack printer cart. I just took two old printer carts, put them on top of each other, bolted them together. I wanted to keep that, so I just visually moved it to the corner of the room in my sketch, rotated it, then came up with the overall dimensions. The dimensions of the cart, dimensions of this cart, and then the overall dimensions of the room. Gave 2-inch clearance on each side of these pieces I was going to keep, and that came up with the overall, width of this octagon desk shape inside. Now for this dimension across here, when you walk in the room, I was going to keep the shelves, but you need, as you walk in, the shelves are at, probably shoulder height and above, a little bit lower also. I wanted to make sure that when you walk in, you're not going to be hitting those, so I gave an overall clearance of 36 inches between the edge of the shelf and the start of the desk. So, 16-inch shelf, 36-inch, minus the overall width of the room, gave me the overall, the length of the octagon. And that is how I came up with the overall dimensions of the octagon desk. Next, I just played with the actual shape of the octagon inside and figured out how to get into the octagon shaped desk and what dimensions I wanted on all the other components. I had a bunch of old aluminum server racks sitting in the corner, and I wanted to utilize the large L brackets, the smaller L brackets that were on top of the frame, and of course the small and large C channels that could be used for either mounting things to or support structures. The first step in a recycled desk design using existing parts and trying to minimize the amount of machining and cutting we'll have to do, and while designing using a CAD solid modeling program, in our case SolidWorks, the first step involves creating the existing parts as they are. Creating the existing aluminum extrusions both in type and length, and also the existing aluminum server rack parts at their current lengths, helps in minimizing the cutting them down unnecessarily by seeing if I can use them in their actual lengths. Of course, I'll have to cut some parts shorter, but starting with what I have, I can throw them into a CAD assembly and then modify them down. In other words, cut them in the program and try to minimize the amount of cuts required for the final desk build. Before I threw in the existing extruded aluminum parts I created, the desktop. This was based off of the room sketch I previously did and came up with the outer dimensions. Almost a square, but a little more rectangular in nature. I then worked on the octagon shape in the central area, and once I achieved the amount of desk space to open space, I then worked on placing the existing vertical 80/20 extruded aluminum models in, and then cut out the interferences with the desktop shown here as the smaller square cutouts around the outer edges. I made the top one large part due to this was the design stage and I hadn't figured out how yet to build the desktop. With the desktop designed, I ended up then throwing in all of the individual components that I had made previously to start forming the desk. And of course, I did need to create some other sizes by cutting some of the corner ones because they were just not the correct length. But as you can see, the desk started to come together as an assembly in SolidWorks. And I was almost to the point where I could start taking count of how many pieces I need of each individual component. See here in the corners, the only things I had to order, I didn't have these on hand. These were specialized 80/20 components that will mount to vertical members that you can actually swivel and make at 45 degrees angles. So I had to order 8 of those, 2 for each of the corners. Underneath, I actually used the C channel from the server racks as cable trays. I only modeled one and figured I would cut them to length as needed. I figured out a mounting method using the smaller angle and bolting it to the underside of the desk 80/20. Then I designed 3 of these actual battery backup support brackets, just made from a C channel and an angle mounted underneath. Then I had this big old 42-inch monitor I wanted to mount, and the large C channel that I had, I can cut to length, whatever length I wanted, and then mount it to the vertical ones with the large L brackets. And I just had to drill a few holes and mount it together, and there you have it. A nice big large monitor mount, all from recycled parts. And before you know it, this desk is almost complete and ready to start construction. I then made a drawing of the desk assembly, your standard plan view and front view with an isometric view in the corner. I did this mainly so I can visually come up with a parts list of the 80/20 structures and mainly focused in my brain on the ones that I had to actually cut down to length. I then went back and looked at my list of what pieces I had and which ones I could cut, and then I planned on how to make those cuts to ensure I got all the parts I needed out of what I had. I switched out the wood cutting blade on my chop saw for a cheap metal cutting blade that was good enough for aluminum and went to chopping away all the components that I needed based on all the measurements within my solid model. The garage work desk I previously created years earlier and reviewed in the beginning of this video had its uses in this new build. I used the drill press I had attached to the corner of the desk to drill all the holes I needed in the brackets and 80/20 components. The garage work desk was extremely helpful in creating this new desk by giving me a solid work surface to use. The battery backup support structures, I tapped holes in the large angle I cut to the width of the 80mm wide vertical beam and attached it to the larger C-channel with 4 countersunk screws I found in my bag of bolts. Now remember when I made the garage desk, I didn't want to make any cuts or as least as I possibly could because I wanted to use the anchor fasteners that I had so many of them. And they work so well at butting up. But now, since I have the custom Octagon desk, I was going to have to somehow connect some of the cut structures that, now that I cut the ends off, I needed some way to actually connect them. I can use angles or make my own custom plates to connect them, but I wanted to use these. So I came up with an idea to actually mill with a 20mm mill, the milling process. Problem was, what I used was a socket. I put the 20mm mill, end mill into the socket. I used some JB Weld to get stuck in there, and then I used a drill adapter. And then the concept was to put it on the drill press and just slowly go in and slowly go down until I got to my depth. The problem was that there's no way of making this sturdy, and a drill press is not an end mill. It didn't work. It would make a small hole, and then I'd start making a bigger hole, and it would just come out all awful. The sides were not round, and it just didn't work. So what do you do next? Improvise. I actually got a 20mm drill, and it worked fine. I could put it in the drill press, and it would, cut out my 20mm diameter hole for the actual anchor fastener. And the only difference was it would have a little bit of a extra hole that would sit inside this little hole on the extruded aluminum, but it didn't cause any structural damage to it, and it worked just perfectly enough for what I need to do, making a desk. I started out by putting an anchor fastener upside down on the end of the extruded aluminum structure and tracing the outline of the area to be drilled. I then slowly drilled the hole out and repeatedly checked the depth by placing the anchor fastener in the hole, and then drilling a little more until I got the desired depth and locked my drill into that depth to repeat with all the other so-called counterboring operations I would do. I still needed to clean up the rough burred edges of the freshly cut aluminum structures. Or did I? Due to they would be out of sight, butted up against another aluminum structure. Of course I cleaned up the edges eventually. One item I didn't have any of were the base plates and leveling feet to put on each of the bottom of the columns so I could adjust the overall height of each column to adapt to any variations in my placement of the horizontal beams. I had to tap the 4 small holes in the bottom end of each vertical beam to attach the plate to it. I ordered leveling feet from Amazon to save a little on the costs. Attaching the plates were easy and the columns were ready. I decided to construct frame components in the garage, and I recruited my younger son to help out. And like every young child, he picked up a hammer and started smashing things. But eventually, he actually came around and started helping out. We went to constructing one of the first H-frames, that way to give us a measuring tool where we can build on top of it and have them all at the same locations. Then we went and stacked the next 2 sets, built them to the exact same specifications, while my son was building the end pieces. The end structures were held together with 12-hole 90-degree angled flat plates that I purchased from 80/20. The sad but joyful time had finally come to deconstruct my first custom office work desk, and I recruited both of my sons for the task of deconstruction since boys are really good at that. And then I did the irreversible cutting of the end cabinet from the rest of the desk and proceeded to deconstruct the rest of it. It was finally time to start constructing the Octagon frame, and I found it easy to put together an H-frame with one of the corner brackets that my younger son put together and attach it to the adjacent vertical column. This made an L shape that could stand on its own, and then I attached the other corner piece to the smaller H-frame that would be located under the shelves against the wall. I then proceeded to attach the first cable tray, and then subsequently the APC battery backup support brackets. I then just had to try out the support brackets with the actual battery backups mounted to them to ensure they supported the weight. For fun, I next mounted 2 designs for monitor mounts. One was a fixed location design based off of a large cut modified angle. The second, which I had made 4 of, comprised of a monitor arm that could extend and swivel greatly and was attached with 2 smaller cut angles. Both mounts would work great. Next was finishing up the 80/20 frame and completing the octagonish shape of the structures. The right side I constructed in pretty much the same fashion as I did the left, and I added in another cable tray to the central area. I then proceeded to add in some monitors to the monitor mounts. I was anxious to see what it looked like. I even took a horizontal dual curved monitor mount and created a stacked monitor mount for working on computers. I had a corner dedicated for working on building PCs, then the next corner was for my CAD computer, then the adjacent corner was dedicated to the gaming/video editing PC, and I had the final corner open for tools and an unused desk workspace. I added in a few more monitors, and then I decided it's about time I better start working on the actual desktop. So I headed to the garage and started the next part. I gathered all the plastic sheets from the Genetix Q-Bot so I can start putting all the pieces of the puzzle together for the desktop. I used 2 sheets of 3/4 inch high density fiberboard, 4x8 sheets, and cut out a left and a right side, and then put the plastic components on top, kind of like a jigsaw puzzle, and then cut out all the shapes according to what I had in my CAD file. After spending all the time of designing it down to the millimeter of clearances that I needed and everything fit together greatly, I forgot one key concept of the building process, and that was, hey, what order of operations do I need to build this in? It's not a regular desk where you have a square or rectangular desk where you build the frame and then you just plop the desktop on top and bolt it from the bottom. Here I totally forgot about, I have 2 layers of horizontal members. One that actually supported the desktop, and then another one about 18 inches above that, kind of mirroring the one below it, that would support all the monitors and tool supports across the top. Now the other problem is the left and right sides of the desktop that would go on had the little cutouts, the rectangular cutouts, or not rectangular, yeah, some of them were rectangular, mostly square, but for the vertical members that came up. But there was vertical members on 3 sides. And the problem with that is, with the horizontal members that were in place on the second layer, the only way I could possibly get it in was to somehow slide one side with those cutouts into the vertical members and then drop it down. To make this issue visually clear, here is the current setup with the monitors in place. Now, if I were to try to slide the left-hand side of the desktop in, there would be a problem with the 2 vertical members, one under the shelves and the one closest to me. The only way I can get anything in was to take off all the upper vertical members of the monitors, and then before you know it, I had to put it all back together, and that's the only way I could actually get the desktop on. The next step was gluing the black plastic plates to the top of the actual desk. I just used some construction glue, and it worked perfectly. I also proceeded to mount the large 42-inch monitor mount on the upper right side. The last item at this stage was putting the 42-inch monitor up, and it looked great. Anchoring the particle board desktop to the 80/20 beams was easily achieved by using recycled server rack cable tie-down strips. The existing larger holes lined up perfectly with the center of the T-slot, while the smaller holes on the cable tie strips lined up perfectly in the center of the 3/4 inch wood. I hung the left and right and surround sound speakers using galvanized steel water pipes. And the open 80/20 frames was great for mounting wall mountable storage screw cabinets. Here's a more detailed view of the 42-inch monitor mount using a large C-channel as a backing. There's 4 bolts with T-nuts mounting the cut-down large L bracket. The monitor is mounted to the C-channel via a cheap TV wall mount that is mounted to the C-channel with 4 bolts. Here is a small strip of C-channel that was used in conjunction with 2 old hard drives taped together to mount the microphone boom arm to the diagonal 80/20 structure. As you can see, my main goal was to be creative in this build. Looking at the original first corner that was built, you can see above I added a shelf to the H-frame, and this corner seemed good for attaching a screwdriver set to the back of the diagonal 80/20. As I peek below the desk, you can see the small C-channel cable tray and the corner plate just above a white workstation I was working on. Moving up and over across to the right side, You'll notice the surround sound speaker mounted to a galvanized steel wire pipe fitting with some tools mounted to a magnetic strip behind it attached to the A20 segment. Take notice of the individual pieces of the black plastic plates glued to the desktop. That's how I made use of all those Q-Bot panels. Believe it or not, this is the cleanest my desk has ever been. You'll notice the monitors have also changed over the last few years. I picked up a double-wide Dell monitor for a good deal on Craigslist a while back, and it's definitely overkill. Swiveling around to my CAD video editing workstation, you'll see it morphed into a triple monitor setup over time. These changes are all easily due to the reconfigurability of the A20 structures. Coming upward, you can see more clearly the shelf addition to the H-frame that was great for storing useful books. It's finished up with a shop light spanning from one side to the other. This light becomes extremely useful when working on anything between the two workstation sides due to the limited ceiling light provided by the room. I had finally finished the ridiculousness of the Octagon PC workstation. Fast forward to now, December of 2022, and you'll notice that 3 of the monitors on the right side are gone and replaced with a bunch of tools and other cool stuff. This is currently the final configuration of the Octagon desk and a prelude to the next video I'm currently making. The gaming and video editing PC side has morphed into the physical workstation for tools, and that PC and all the attached peripherals are being used in creating an entire room to be called the Media Creation Room, with a new 8020 desk being created and the room being transformed from a guest bedroom into a video editing and creation room. If you enjoyed this desk, stay tuned for the next one. Thank you for watching this video on recycling a Genetix Q-Bot and making 2 unique desks out of it. If you enjoyed the videos, please hit the like and subscribe buttons and share with your friends. And if you have any questions or comments, put them in the comment section below. And just for a spoiler alert, this room I'm sitting in right now is actually the next video that I'm going to be making and currently making. I'm almost finished with this room, but it's going to be the transforming a bedroom into a media creation room. So stay tuned for that next video.